Thanks for joining this session on physical science. We're going to be talking about lenses and optical instruments. Now, you do have a video on your student portal that goes over this in more detail. We're just going to be talking about a few certain concepts and a couple practice problems. So we learned in the last section that refraction is the bending of light as it goes through something. So you have the incident, right, that hits the piece of glass or plastic or whatever it's going through, and then the refracted ray, which is the light leaving it. And that refracted ray has been bent. And our eyes and brain look at this and say, well, light normally moves in a straight line. So we're seeing an object that started out up here, right? This is the light that we're seeing. It was over here. And this is why refraction can change the image. It can make the image look different than the original object and make it look like it's in a different place. Now we have two main types of lenses. We have converging lenses, and so if you have light coming in parallel to the principal axis, it'll go through and then bend so that it all comes together. It converges, and the point where all those light rays cross is called the focal point. Then we have diverging lenses, where light coming parallel to the principal axis will spread out or diverge. And in this one, again, you've got to think of straight lines coming back from the refracted rays. And the focal point is actually going to be where those imaginary lines cross. Okay, so if you have an image forming there, it's a virtual image. There's not actually light rays crossing there to make that image, but that's what your brain interprets it as being right there. So you get that virtual image. And this image can appear in different places in different conditions. So we don't have time to go over all of it because we've already made a video about it on your student portal talking about, if the object is this far away from the lens, where will the image show up? So you need to pay attention to that. You need to go watch that video and then go from there. Now, when we're talking about lenses, we use this formula, and it's the exact same formula we had for mirrors. So when we talked about curved mirrors, we had this formula for heights and distances. Same formula, entirely exactly the same formula for lenses. So you have the height of the image divided by the height of the object, and the distance from the image to the lens divided by the distance from the object to the lens. Remember that S is always distance, and just pay attention to your I's and O's. So the object, the thing that's, making this original image is O, and then after the light goes through the lens and it's refracted, then we deal with the eyes. So the image is the height of the image and the distance of the image. So you just fill in any three of the values, which you'll get in the problem, and then cross multiply to find the fourth one. So here's an example question. An object is located 300 meters from a converging lens. The image formed is 150 millimeters high at a distance of 90 millimeters from the lens. What is the height of the object? All right, so we did the distance of the image. So we fill in those three numbers, and then we're left with HO, the height of the object. And that's what it asks us. What is the height of the object? That's what we're trying to find. So now we just cross multiply. So if you remember that from math class, you take your diagonal numbers, you multiply them to each other, and these will equal to each other. So 360 times 150 gives us 54,000, and then that's equal to HO times 90. And now divided by 90 of 100. Okay, we have a second practice problem here. If an object is 70 millimeters high, so that's the height of the object, it's placed 40 millimeters from the converging lens, so that's the distance of the object, and the image is formed 120 millimeters in front of the lens on the same side of the object, so that's the distance for the image. So we're left with what's the height of the image, and that's what it actually asks us to find, so that's good. Just again, we cross multiply. 40 times hi is equal to 70 times 120. So 70 times 120 gives us 8,400. Then we divide to find our final answer. And lesson 5.3 talks about optical instruments as the next reading, and it goes through a lot of things about a lot of instruments. We've got magnifying glasses, eyeglasses, cameras, and telescopes, and microscopes. So all of these are discussed in another video, the one on your student portal. Definitely watch that. The only one I want to talk about right now is microscopes. So a compound microscope uses two convex lenses. There's the objective lens and the eyepiece. So the objective lens makes an image here between the two lenses, like inside of the microscope. And then, no, sorry, everything's still popping up there. Okay, so your objective lens makes an image here, and then the distance from that image to the eyepiece is less than the focal length, and that's going to end up magnifying the image that you end up seeing. So this is something where, again, you want to watch that other video about the different types of lenses and how the images will look depending on where the object is placed, that kind of thing. But the idea here is you've got two lenses. They are both magnifying the image. So to find out how much larger the final image is, you multiply the magnification of both lenses. So you take the number for the objective lens, multiply that by the number of the eyepiece, and that tells us how big this final image is going to be. So we do have a practice problem for that. If you have a microscope with an objective lens that has 3 times magnification and an eyepiece with a lens that has 30 times magnification, what's the total magnification seen by the user? So you just multiply those numbers together. 3 times 30 gives us 90. So if you use this microscope, what you're going to see is an image that's 90 times bigger than the actual object that you're looking at. So that brings us to the end of this section. If you have any questions, don't hesitate to contact your instructor.